starting. One, thank you for coming, and two, this is our last official scheduled regular colloquium for the semester. But we will have job talks by candidates who will be here for our tenure track statistics search. They will be here next Tuesday, next Thursday, and the following Monday. Flyers will be up for those in just the break room, and there should also be some sort of electronic, I think Ross will be sending out emails with specific information about their schedules and also their research talk. So I'm going to get out of the way, and I'm going to let John take over. Who knows our speaker much better than that.
A lot better if I could throw a couple stories and people start calling me out about my editing. No, we're glad to have Dr. Fred Coon, officially Dr. Fred Coon now, as he ended and has completed. So we are walking in a few weeks. Looking forward to that. But Fred's research areas you'll hear a bit more about with probability literacy, also problem posing, project-based learning, and problem-based learning, which is really neat. He's got some good ideas and some cool things going on there. So without further ado, Dr. Fred Coon, the floor is yours, sir.
Thank you. So the handout I gave you, we'll get to in a minute. There's not really a side one or side two, but I gave it to you as a reference because you can't really read the information as it appears on the slides up here. So I was researching probability literacy, and it is a very, very broad topic. If you've dived into it, and it's just in a little bit, you would have seen it very quickly. Today, what we're going to look at is just a part of it. We don't have time to discuss everything in the 40 minutes that we have, so I was just going to dive into just a single section of it. The research was centered around trying to understand students' understanding of probability literacy, namely around a couple of knowledge elements of randomness, independence, and sample space. Those are the three topics I focused in on. The little bit of things that occurred as I was doing that research, though, was it was very difficult to completely separate any one aspect of probability literacy from everything else. So one of the things that came up as I was presenting my findings, as I was going through all that data, was that the beliefs and the context and all these other things that came out were having an influence upon randomness and all these other pieces, and vice versa. So those things, it was difficult to kind of piece those apart, but I did the best I could with that. So this particular topic that we're going to be looking at today is going to strictly focus on the randomness. The sample space independence and other pieces will come up, but the talk is mainly centered around the randomness aspects that I found. One of the reasons why I was focused on probability literacy, it's kind of threefold. I don't know if I'll get to all three of them today, but one of the things is that probability is one of the things that is very prevalent in our society. From a policy perspective, one of the things I decided at the end of this research that I'm going to continue is that the third course in North Carolina really should be centered around a probability course rather than being another algebra course. Currently I have to teach full-time in CMS, and essentially what we do is we teach them 3 algebra courses. And I'd really like to see that change because probability is something that students see once they leave high school, regardless of what direction they go into. They're tracked using probability models, or they can use the probability models to do other things like get jobs and whatnot. So I think that's something to think about. The other thing is that there's not a whole lot of data about this topic at the high school level. And I think that that is kind of injustice because one of the things I did discover, and I'll talk about here in a minute, is that we're not really seeing the progression through some of these topics or the grasping or the solidifying of their understanding at the high school level like we probably should be if the material were to continue to be taught at the same level. Another thing that kind of popped up to me as I was going through this was this idea that in English class, people really don't say, well, I can't read. It's kind of an embarrassment. But we do say, I hear this all the time, especially at the high school level, of, oh, I'm not good at math. And I'd really like to see that change, at least from a cultural perspective of, I'm not good at math. Well, that needs to be changed into, I need to become good at this. Because a lot of it's a perspective issue. Because ultimately what we're trying to do is we're trying to equip students with the ability to do math so that they can do other things. It's kind of like I learn to read so that I can read to learn. Same idea, but we need to equip them with their probability skills so that they can go forward and do probability with other things, rather than just learning probability for its purpose. That's kind of secondary, and that's my 20 years of teaching high school coming out, so I apologize for that. But anyway, Gal just defined probability literacy into two major domains, the knowledge elements and the disposition elements. And he broke those down into further. So the randomness, independence, and sample space that I looked at with my study were part of the knowledge elements, as were those were the big ideas, as were language, context, and figuring probabilities. Those are the knowledge elements, kind of the procedural stuff, some of the terminology that goes along with it. And then there are also the disposition elements. And the idea behind the disposition elements were that those are the beliefs, attitudes, and critical stance. Those are the way that they kind of interpreted, what were the lens that they were looking through things. And the idea is just the pure knowledge of reading through the material and having that knowledge and doing something with it versus actually being able to filter it to come across a conclusion of some sort. And I think collectively that's what ultimately we're trying to do here. And I didn't go after trying to get all this information at one time because I wanted to make sure that I gave each individual component its due justice. And as I dug in on just the big ideas here, I found that there was a lot more to be done just on the big ideas than what I've done so far. So going forward and digging in on just randomness per se is going to take a lot more than to make it complete, although I think I do have a fairly solid or solidified setup what I have here. One of the big ones that I came across, and one of the things I was using as a jumping off point was Piaget's 3 stages of development when it came to thinking about randomness. He suggested that students, when they're around the age of 12 or 13, should be entering into the 3rd stage of development where randomness is starting to become solidified in their thinking. And one of the things I found through my study was that is not necessarily occurring with high school students. It definitely is probably progressed from the point where they were previously, but it's not really progressing as far or as quickly as it could be otherwise, I think. A couple other big things that came out, and we'll talk about the hot hand in depth in a minute, but the recency was suggested as being something that was going to be a big issue for the students. Mainly the idea there is positive recency is that the students are going to assume the next event is going to be identical to the previous events, basically because they're the same thing. You flip the coin, you get 3 heads in a row, the next one's going to be heads because the last 3 were heads. Negative recency is more of an adult, young adult at least thing, where you view that the next event is going to be different strictly because the other events were heads, the next one's going to be tails. One of the big things I came across with randomness was that did not exist hardly at all with any of the students I interviewed. And we'll talk about that more as well too. But there was one student out of the 10 that I interviewed who displayed some recency, and the others, even though it may have initially appeared like recency, when I dug deeper, I found other things going on with them. And then there was the hot hand phenomenon. Anybody familiar with the hot hand phenomenon in basketball? A couple of your heads are shaking up and down. The study I'm citing here actually debunked that idea, that hot hand was a phenomenon at all, that they found that the hot hand phenomena is just something people perceive to occur. It doesn't actually occur. There have been studies since 1985 that have actually debunked that debunking. And it's interesting that they actually found that if you look at the highly skilled players, you do actually see streaks occur. So some of the players, like back in the day, I'm dating myself, I guess, although the white beard's not doing that for me, is Michael Jordan, who would go on streaks. And he actually commented after a game that the goal was 10 meters wide and he couldn't have missed it. It was huge. And that's an interesting phenomenon. But for our purposes, or for my purposes on this study, it didn't really matter whether it was a true phenomenon or not. Because I was looking at how did the students perceive what was going on with that. So you can look at the sheet I gave you. On one side I gave you the tasks. One of those tasks was the hot hand phenomenon. And what I did was I asked the students to read through that and tell me what they came up with. And we'll dig through, and I have actually an example that we're going to look at here in a moment of a student's response to that. But it was really kind of neat to see how they viewed that event and why they thought the next hit was going to be a hit or not. And then when you talk about skill being a part of the situation or part of the event versus skill not being in play, it changed the dynamics of the discussion as well. So anyway. So this is what I did. Did a multi-case study, and I eventually tried to group the students into groups, and that was what on the back side of the task idea there. I'll show you my LUM there in a minute here, but The idea was to try to group the students into eventual groups based upon their skill levels. I did semi-based task interviews, semi-structured task-based interviews, and the idea of the task was a jumping off point. So when I did my pilot on this, I went through probably about 12 different tasks, whittled it down to about 4 is what I end up using for the main study. So you have 5 in front of you, and I end up throwing out one of those after the second interview because I just wasn't getting to it. I was getting so much rich data from the other 4, it was unneeded. And there were some contextual issues that we can talk about on that 5th one that actually caused me to throw that out as well. Ended up doing it with 10 students. Half of them were actually right down the road from Lincolnton. Probably shouldn't have said that, oh well. But 8 of them were done independently and 2 were done as a pair. The other half of the students, half of them were from the rural setting, half of them were actually from a Saturday program inside of Charlotte. So a fairly diverse group from that perspective. The idea was to get students across all ability levels. The problem with that is all the students that took place in my study self-reported as being an A-B student in their math classes. So I got these little ones and more or less no one else, at least according to the way they self-reported. I don't know if that's true. I reached out to the schools as best I could to try to gather that data, and they were unwilling to release that data to me. So I had to go with what the students self-reported. Yeah, so there. So one other big thing I was looking for was, were the students really at that 3rd level of development? Was their randomness really solidified? So one of the things I did in the pilot studies, I interviewed 3 students. I ran through a bunch of the topics. They were more or less the same age grouping. The demographic was very, very slim, though, because all of them had AP calculus, so these were all high-level students, which made it actually a really good test process for me, in my opinion. But the other thing it also did was it allowed me to develop the LUM. And that became critical as I was starting to process the students' understanding, was processing all the data that I collected from the students through that LUM. And the LUM is almost entirely based upon the data I got from this. It was critiqued from other places as well, but that was the big influence on it. By the way, if you have any questions or comment as we go, feel free to jump in there. I'm used to students interrupting me all the time, so it's not going to bother me. Initially, one of the things I wanted the students to do was to write things down. Rubel mentioned that students would write things differently than they would speak about them, so I wanted to be able to compare those 2 different trains of thought. I found it to be extremely difficult to get students to write things down, which will become important later on, but they would write things down and be minimal. They might just write down the answer is this, and they would write nothing else, even though I insisted that they write down their thought. So some of the responses I got, I'll show you a couple of them, but some of them were just like, this is all they're writing. That was it. So that was a difficult aspect that was kind of had to be thrown out as I went through. All the interviews were videotaped. I actually am a little bit of a over planner when it comes to this. I had 2 videotapes, and I also audio record them, which was great because on the last interview, one of my video feeds failed. So that was great to have the backups. Each student's understanding was gauged through the LUM. And if you can flip over to the back side of that and you can look at that. What I did was I created a document that would allow me to rank the students from high to low. And from beginner to advanced is what I ended up doing. So they got a level 1 versus a level 4 through each individual topic of randomness, independence, and sample space. And each stage as they're moving through that, they're supposed to become a little bit more abstract in their understanding of the topic. And what I did with independence and randomness especially was to start adding pieces in there that would, they had to have achieved more of the components. With independence, it was a little bit easier to do. They essentially, I set it up so they had to have all 3 to become a level 4. The other 2 were a little bit trickier to deal with. And the big piece for the sample space one, if you look at that one in particular, Common Core and a couple other sources were citing that students' ability to use the information was a big deal, which is why it occurs in all 3 topics in that category, as well as not being prompted to use the sample space. And again, I'm not spending a whole lot of time talking about sample space here, but I thought that was worth mentioning as I go through this. And also you can see that in there, under the randomness section, I mentioned the idea that they are using recency. There's some evidence of recency. There's no evidence of recency at all. They're using the idea of what was the actual frequency of the event to make a prediction, or that they're even commenting about the fact that the event is unpredictable, which very few students actually made note of, that some of the events were unpredictable. In some cases, they also talked about the idea of it not being ordered, or not having an order to it was also in there. Those are the 3 tasks on the other side of that, or the 5 tasks rather. Some of the big things that came out on these tasks as I was going through them are these ideas. And these don't necessarily directly relate to randomness, but I did want to kind of let you see the broadness of how these topics came out according to the students when they were starting to work through them. So one of the big things with the hot hand task is about half the students talked about the skill of the basketball player as being a factor, which completely negates any independence discussion that would be occurring in the situation. With the black and white task, one of the really interesting things that popped up had to do with the language or the context of the problem itself. The student had never seen the word die removed from the context of someone being deceased. So the student automatically assumed that we were talking about dyeing something, as opposed to dyeing it black and then dyeing it white at random. And he didn't quite understand that context at all. It took about 5 minutes for us to both get to the same place where we understood that what we were doing is we had a dye and we were rolling it. He didn't understand that at all. It took me a while to figure out what he was referring to on that one. Fake flip was one of the really interesting ones when it came to randomness, because almost all the students mentioned that heads was more likely, in spite of the fact they also said that they knew each side had a 50-50 shot. Furthermore, heads had to be the first one, or heads was more likely to be the first one, which was, again, really interesting because they also simultaneously said that it's a 50-50 shot. It was really interesting to see how that connection played inside their brains as they went through that. Anyway, I already kind of talked about that. Any questions on what you're looking at with this document here, or what you notice on it or anything? Well, I'm going to get you involved in this soon, whether you like it or not. All right, so some of the big things, like I said before, randomness did not really appear at all. And I thought that was kind of a big deal, is the fact that randomness didn't appear. I'm not trying to refute something that someone else has found. I am admitting that the population, although I think it was the sample I got was saturated as far as the response I was getting, it was not a broad sample size. It was a very, very confined grouping. 5 urban students, 5 rural students, but beyond that, they're all upper level students. They are all students who are, by all means or self-account, good at math. So that if I were to look at the lower level students, would I find more recency? Yeah, I think that it's possible. So it may be a phenomenon with the upper level students where that's the understanding of randomness is so well defined with them already that it's no longer an issue. That wasn't really talked about in Bryan's News when they presented their findings. They just said it was just kind of a thing across the board. They didn't really specify that it existed with one group versus not existing with another group. The 2 other big things that kind of popped out was this idea that the randomness was an unordered list. That was something that was really interesting to talk about, is that they really didn't have, or they did have the ability to see random events as being unordered. Some of the students that you'll see actually talked about the idea that the events had an order to them, or they would expect the events to have an order to them of some sort. Like, I got 10 heads in a row, next one can't be heads because I already have 10 of them in a row, there's an independence discussion there that definitely can occur. But from a randomness perspective, they were paying attention to the fact that there had to be an order to the results that you came up with. And the other big thing was that they kept suggesting that I should be able to predict this random event. The next flip of the coin should be predictable. I should know approximately what it's going to be as we move through that. Now, what I'm about to show you is not something I showed the students. This was not part of the interview, but I thought it was a neat little thing to go over with people when I'm discussing the findings. It's a little small, so I apologize. I should have printed this out for you, I guess, maybe. But this is 4 columns of flips. One of the columns is a real flip. The other 3 are fake. And then the question I have for you, and some people have gotten this right. I'm interested to see how many people in here get it right, but my father, the engineer, got it wrong. And when I told him the right answer, he got almost angry about it. So, which one's the real list? A, B, C, or D? I'm hearing A. Anybody refute that? Kind of hard to see, I'm sorry. A or B?
I prefer B.
B. Why B? That's 2 votes for B.
Because you're still finding a lot of pairs, so like you're finding like the same thing happening multiple times, but it's more evenly distributed across. It's not like heavily favoring one over the other.
Interesting. Why A?
Because we talked about streaks earlier. Similar things like this, like given different probability distributions, how people come up with them versus how they actually play out,
Mm-hmm.
and like generalization. There's a good number file video.
Mm-hmm. Yeah, actually a lot of the research shows that when you do this, if you were to actually do this example with 40 coins, you're actually going to more than likely end up with a list that looks more like A than the other 3. And it's really weird. Some people think it's really weird that it happens, but we're paying attention to the fact that it's a random event. So why does the coin care about the last flip? We're assuming here that this is not a skilled event. I have people tell me that there's a way to learn how to flip a coin so you land on the same thing every single time. I'm not sure I believe this, but maybe the issue is I don't believe that someone would take the time to learn how to do that. But you do actually end up with these long streaks of things occurring when you do these random events like this. And that was one of the things that was really interesting when I got into talking with the students about that, was that this list was not something very many students came close to recreating. The other lists were actually things they came across creating. And one of the things that a lot of people were drawn into is the fact that B, C, and D are almost exactly 50-50. They were designed, purposely designed, to be 21, 19, and 22 tails each, respectively, as opposed to list 1, which is 12 tails. So it's this idea that we're trying to match up. We know that if we were to flip this coin an infinite number of times, half of the outcomes would be heads, half the outcomes would be tails. We're not doing it an infinite number of times. We're only doing it 40 times. So the smaller group doesn't necessarily have to look like the bigger group. All right. So I have an example here, and this is student 8 and student 7 who are kind of discussing this. The main focus here is on student 8, who will be on your left, right? Correct? I don't know my left or my right, but anyway. We're discussing the fake flip here. And what student 8 has done is he's created a series of flips that is exactly 50-50 and is almost completely symmetrical. He started off with 2 heads, and then it's a alternation of heads, tails, all the way down to the end where he puts 2 tails. So it's exactly the right number of heads and tails, quote unquote, and he is creating, this is him creating his reasoning on why that has to be the correct answer. So.
Because it could happen, but technically speaking, it shouldn't.
Shouldn't it?
Yeah.
Why should it happen?
Well, actually, I worked that out. Like, it could happen, but just the chance of it happening, you mean?
Yeah, less of a chance of.
Okay, so you think there's more of a chance of getting a lot of alternation in the list?
I thought it was really interesting. On the surface, it's like, okay, yeah, we're done with that, right? But I thought it was really interesting, and on his thinking, he went on to talk about how if it's a random event, or we're flipping a coin, there should be lots of alternations. We should see a lot of things occurring as opposed to just the same thing occurring over and over again. This could be expanded into talking about the dice example, the double 6 one, where we're talking about the idea of rolling 5 and 6 versus rolling 6 and 6. That was another interesting place where students had similar ideas that we should see a variety of things occurring as opposed to seeing just one thing occurring. One of the students, and I think I have that video for you to show you here in a minute, where he was actually talking about that idea, the idea that a 5 and a 6 was more likely because it was different. Just like this student is talking about the idea that an alteration between heads and tails is more likely because they're different. And I think that was really an interesting aspect into their understanding, or his understanding of randomness is talking about this idea that it has to flip back and forth, back and forth, back and forth, back and forth. Anyway, comments on that?
So, did you follow up with these kinds of questions in all of these fake flips? So did the students pick what they picked because they thought that it was not possible, or they thought they could fool somebody else that it was not possible?
Yeah, that was something else, is that they were making lists that they thought would fool somebody else.
They were fooling. They knew it was not, but...
Well, so, yeah, that's the other perspective of, I'm essentially putting them as a third party here, right? Yeah. Is this really their belief about that situation, or is this what they believe everybody else believes? In this situation right here, this student believed that what he'd created was what would occur. This would be the fake list that somebody would believe because you would expect to see that, right? He would expect to see that. And that's something a lot of the students did say, is that essentially this is the list that people would fool people because this is the list that would be most expected. This is the list I would expect. Now there were a couple of students who actually pushed back on that, saying, well, it's not what I would believe. There were a couple of students who actually said this, like, no, I don't think this is the most likely occurrence, but this is what other people would believe. And that in of itself was really interesting to hear them say that, because it was an indicator of how well they understood the randomness. And those two students actually said that, actually scored in the level 4 on randomness. They were the only 2 students to score that level. Not necessarily because of those comments, but it was a consideration. I feel like I skipped something. Anyway, some of the things that came out about this that kind of struck me was how this fits into the educational world and in terms of informing teachers on how to teach probability. And one of the things that is very much true, and this was even true if you look at the research back in the day when new math came out, is that a lot of teachers weren't prepared to teach the material itself. So going forward, I would think that in order to do this well, we need to make sure that we're equipping teachers with the right knowledge that they need. But one of the things that came out in terms of informing future teachers is this idea of, well, I should have gone back. I can go back and show you the sample space example maybe. But the idea of using sample space as a tool. And I didn't go through a whole lot of detail on sample space for time. But one of the things I found is that the students that were able to discuss sample space and create sample space and use sample space effectively also had a much better understanding of randomness. So I'm not necessarily implying that there's a correlation to those two things, but there is definitely an association between those two things. So when a student is able to discuss their sample space, they were able to access the sample space in order to talk and discuss their topics. Like for instance, the double 6 question in particular. There was a student who actually used the sample space to change their mind. They actually came up with one answer, and they used the sample space to change their answer based upon just looking at their own sample space that they had created. And I saw that across the board as students had a stronger ability to create sample space, let alone use it unprompted or create it unprompted, they also had a better understanding of randomness. And I think that association implies that there has to be some connection between a student's understanding of randomness and their understanding of sample space. Whether one supports the other or one encourages the other, I don't know. That would be something to look at for future, but it's definitely something that is there to talk about. And answers did flip-flop. There were multiple students who changed their answers when they'd created the sample space about something, or even changed their reasoning about something in relation to a random event. One of the other things that popped up was this idea of using task as a form of assessment. And I put that up there with caution because we're in the day and age of test everything to death. And I don't necessarily think that's always the greatest thing. But the amount of rich data I gathered out of this and the amount of data I gathered from understanding what the students understand about their thinking was really rich. So using these tasks as a form of assessment would be great from the perspective of you get so much insight to what they're thinking. But going back to one of my previous mentioned findings is that the students just didn't really want to write things down. They did not want to explain their thinking on paper. So if you're going after the correct answer, using the task isn't necessarily a positive from that perspective, unless you can actually get them to write down what they're thinking about in terms of that. And that has been something I know that's been a struggle for teachers for a long time, but it is something that has popped up on this, is you don't really gather any useful value from using the task unless you're actually getting the students to explain what their reasoning is. The other big thing that popped up is when students were able to present a parallel scenario, and this was really neat to see happen. When they were able to present a parallel scenario about something, it was also indicative of the fact that they had a better understanding of what that scenario was. So if I remove the parallel scenario from the situation and graded them strictly on what responses I got, those students who created those parallel scenarios had higher scores across the board in the 3 topics, which was really kind of a neat little thing. There was one student in particular who, when she was talking about the hot hand task, she was talking about the randomness of that 4th shot. And she made the parallel idea of a woman having 4 boys or 3 boys in a row. What's the gender of the 4th child? Is it more likely to be a boy because of the 3 previous ones? And one of the interesting things about this is she was completely neglecting skill from being a topic of discussion in either scenario, which was interesting. But she used that scenario as a basis to defend the fact that she didn't know what the 4th shot was. Pardon me. Anyway. So this is student 9. Pardon me. And he has created a sample space here. He's already previously answered that he thinks that role 1 is more likely than role 2. Role 1 being that you'll get a 5 and a 6 versus role 2, which would be that you get a 6 and a 6. I've already at this point I've presented the idea, well, what about the idea if we're trying to get 11 or we're trying to get 12? And he sticks with his answer. He hadn't changed his answer at this point. He sticks with the answer, but the thing that came out when I did this is he actually finally explained to me what his thinking was. And it was kind of a neat little discussion we had because of the way he answered, what he came up with as an answer. He said that the sum of 11 was more likely. He said that giving a 5 and a 6 was more likely. With that said, he also didn't create a complete sample space. In fact, his sample space was very interesting in that his sample space included the number 7 for using 6-sided dice. He caught it after a little bit of poking, but he didn't create a complete sample space, and the sample space he did create wasn't in of itself completely correct. So he does not have a list that has 5, 6, and 6, 5 on it. All right? He doesn't even have 1 paired with everything on the list. So that's a little bit of the background, and his response here is really neat to listen to.
What were we talking about the sums? So like for instance, a 6 and a 6 gives us 12. Yes. A 5 and a 6 gives us 11. Right? So of those sums, is it more likely to get a sum of 12 or a sum of 11? Or are they equally likely?
If we're talking about sum of 12, then I guess it would be more likely to get sum of 11.
Why?
Because again, I guess I'm still thinking about like it's 2 different numbers, so it's easy to get 0.
So I don't know if you heard that last part. He says it's easier to get 2 different numbers. I thought, oh, okay, so that's your reasoning. So he has the right answer. Role 1 is more likely, but the reasoning is just, it is completely disconnected from anything dealing with sample space. And this is one of those examples where I was really kind of impressed with the fact that this is the opposite end of the spectrum. This student claimed to be an A student in his Math 3 class, Math 2, one of those, either 1 or 2, I forget which. And he is getting the correct answer there, but his reasoning is just completely disconnected from what's actually occurring in the situation. So And he's not even taking into account the fact that 5.6 and 6.5 is going to be two separate events in the sample space. He hadn't reached that space yet. So that's a really interesting discussion. And he wasn't the only student that came across something similar to that in our discussions. It was just one of the best examples I came across to kind of relate how students saw that situation. Anyway, I think my voice is failing me, so I'll speed up. I have till 3:45 or 4 what? What's my cutoff time? Okay, so I have another video, but that's for the sake of time. I can stop there if y'all wish. So for future research, the things I'm looking after at this point is to try to collect more samples about the big ideas. What I have is saturated, I feel like, but I think I need to get a more diverse population to look at here to really solidify it a little bit better. But also I need to look at the other topics. The idea is the LUM you have in front of you there, that's just for 3 pieces. There's a lot more than 3 pieces that belong in probability literacy. So the idea is to build to an LUM that we can run through a student's data through and be able to definitively say this is where they are. And at that point we are able to classify them into a beginner, intermediate, or an advanced student in probability literacy. And I think that has value for us, both from a perspective of being able to figure out whether they are good at particular topics or not, or what their understanding level is, or what the association might be, as well as looking at going forward with policy as far as what does mathematical curriculum need to look like in the future, and how we test it too, I think is another big one that we could look at with that. And then again, I'd like to go back and double check the recency aspect with another population. And one of the big things is the sample space issue. What is the association? Really go through and dig in on that one especially. What is the association between sample space and randomness? How do those two link? And something I haven't even really mentioned here because of time is that I also saw that students who had a stronger understanding of sample space had a slightly lower understanding of independence than students who didn't have a good understanding of sample space, which is interesting too, and counteractive to what I thought it would probably be. So anyway, so yeah, if you have any questions at this point, I'll open it up and ask away, and I'll do my best to answer as I can.
You look at the conditional probability.
Yeah, that was something I really played around with at first to see whether I wanted to deal with that.
So that would be the one that would connect the sample space with independence.
Yeah. I was really focusing on making sure I could fit in everything into a time frame, and I really played around with the idea of whether conditional probability would be a good fit for this. And ultimately I went with eliminating it because I was looking at the opposite side of that coin with independence. And I really wanted to make sure that I had a good understanding of those 3 pieces. And probability, or conditional probability, is sometimes something that can be really complicated with students. And I thought it might muddy the waters a little bit too much for this particular study. But it is something going forward that I definitely want to include in to the discussion as well. Yes, sir.
So were these all the tasks that you gave the students?
For the main study, yes. Initially, I had about 12 that I kind of played around with the pilot study. But when I started the main study for this, I gave them those 5 tasks. The last one, which the straight lottery question, I actually eliminated after the second student. It actually created more load on the students than was really useful. They spent so much time trying to understand the task itself, which is an interesting discussion in and of itself in terms of context of the problem, which is a disposition element. But that was a really interesting thing because a lot of students, or the 2 students I used this with, had an issue with processing what was going on with the task. And the big issue with that was they saw consecutive numbers being 1 through 6. But if you got 1, 2, 3, 5, 4, 6, that wasn't consecutive, and that wouldn't be considered to be consecutive numbers. So there's a lot of discussion on how you play the lottery and can you get this number, what does that mean? And so it was eliminated for that perspective because it just created too much of a load for the students to deal with.
The reason why I was asking is I haven't had that much probability or statistics, but I think these are all Bernoulli trials, if I'm not mistaken.
Well, yeah. So the idea was to keep them simple.
So but mathematically, isn't it true that once you start accumulating
Well, if you're talking,
Complex the equations for it.
well, I mean, if you're talking about, one of the things that came up in the discussions with students is it was like with the hot hand task, is that that's not really going to maintain or be stayed at a 50-50 shot, right? The player is going to increase in skill or decrease in skill over the course of time, so you're going to actually see that statistic change over time. So in that case, yes. But with something like flipping a coin, ultimately you're still dealing with 50-50 on that.
I was mostly looking at like the black and white example.
Yeah, one of the interesting things that popped up with the black and white example was students insisting that the white one had to occur in six rolls, which goes back to another topic that could be included in this, is the idea of expectation, or the expected value of the outcomes, you know, because they're like, every 6 rolls you should get one, which is an interesting lead-in for a teacher to deal with, but yeah. Did I answer your question?
Yeah.
So how much probability do they get in high school, and where is it usually found?
Most of the probability exposure they get comes from 2 classes, AP Statistics, which very few students actually get access to, and the other place they get it is in Math 2. So all these students at this point should have had the exposure to probability that they would get in a normal high school curriculum.
Is that the case with the new Math 4s that are coming out? Because I know they're adding more of a stats probability package.
I have not seen the curriculum for Math 4. I've been so wrapped up in doing this that I haven't had a chance to even look at it. I understand that would be a nice addition. I would agree with that, but it'd be a nice differential path from students taking just pre-calculus or AFM. Either this, I answered everything, or this was not great.
Questions, comments? Thank you, sir.
Thank you.
Appreciate it.